Hey folks, welcome to .NET Conf. Today I'm excited to talk to you about some real-world .NET profiling with Visual Studio. I'm Nick Karpinski. I'm the dev lead for the Visual Studio Profiler and the diagnostic tools in Visual Studio. And my team's mission is to democratize profiling. We want anyone to be able to use the tools that are available to you in Visual Studio and go ahead and make a positive impact on the performance of your application. And so I want to do that today using some open source libraries. Before I get started, I just want to put a plug in for Visual Studio 2026. We are now launching it. It's optimized for .NET 10. It's great. We're now doing monthly releases of it, so you get fixes faster. It's significantly faster. The new UI looks great, and it has a bunch of integrated Copilot features that are going to make you faster and more effective at development. And specifically today, I want to talk about the new profiler agent that's available. But before I get started in that, I want to discuss how do we optimize in the real world. And so when I think of performance optimization, I kind of think of this flowchart where I basically start on the left and I work my way over to the right. So starting, I want to know, do I actually know the issue that is affecting performance in my application? If not, my first step is to run the profiler. And knowing the issue can't just be, hey, do I think that it's the JSON serialization that's taking a while? Using and running the profiler tells me exactly where my time is being spent in my application, and it gives me a point to focus on for my investigation so I get the most amount of benefit for the least amount of work. Once I know what the issue is, my next question is, do I have a benchmark? You can think of a benchmark as like a small artifact similar to like a unit test that you can run, you can profile, and you can use that to figure out if the changes that you're making are actually improving performance or detracting from performance. Luckily with .NET, we have the awesome BenchmarkDotNet library that really helps make running benchmarks and capturing statistically significant data very easy. So if I don't have a benchmark, I generate a benchmark. And then once I have the benchmark, I can kind of fall into the optimization loop. And this is where the measure twice, optimize once comes from. The idea is we want to go ahead and we want to run our benchmark. We want to get a baseline for what the performance is. From here, the profiler and performance report should tell us where time was being spent, and then I can start to formulate different hypotheses of changes that I can make to my code. I'll launch into my favorite part, which is going ahead and editing the code. And then once I'm done editing the code, I run that benchmark again, remember, measure twice, and I need to validate, did I actually improve the performance or not? And so when I get over to the right, I can say, compared to my baseline, did things improve or did they regress? If they improved, Ship It Squirrel says, hey, let's go ahead and let's put a PR for that and let's get that back merged into main. If not, I can go back into my optimization loop. I can undo my changes. I can try a different approach. Or I can maybe even go back and run the profiler again and make sure the thing that I'm trying to optimize is what I should be optimizing. And the cool part is with Visual Studio 2026, we now have this Copilot profiler agent that's going to help you out with each step in this optimization workflow. And so that's enough slides. Let's move onward to the demos. And so for this demo today, I want to show how we can improve the performance in an open source repository. And like I said before, my team's mission is to democratize profiling. And so the way I've chosen to try and achieve that is I went and I grabbed the NLog repository. If I go to the NuGet gallery and I look at the most downloaded packages, I can see down here at, I think, 58 is NLog. It's a super fast, super popular logging library for .NET, heavily optimized, but I think using the tools in Visual Studio, I'll be able to go ahead and make a positive performance improvement on it. So I don't have any experience with this repository. I've gone ahead and I've cloned it, and I can see there are a bunch of packages that come with it. It looks like it has a bunch of tests, which are really cool. I see this NLog regex tests, and I can see there's this colored console target tests. And if I scroll through here, similar to benchmarks. Tests are, small artifacts that we can kind of test in isolation. Benchmarks give us that too, and so you can almost think you can kind of look at tests and transform them into benchmarks pretty easily. And so I can see there's this colored console target class that does something, and then it's going and it's asserting some output. And so I want to go ahead and I want to see if I can try and improve the performance of colored console target. And so I have created a NLog benchmarks project. I could ask Copilot to do that for me, but in the essence of time, I just went ahead and I've created that real quick ahead of time. And I've created this color console target benchmarks file. And so in here, I would like to see if I can create a benchmark that's going to help me optimize the performance. And as you can see, Copilot Next Edit Suggestions already got excited and wanted to try and help me with that. But I don't want to use the Next Edit Suggestions here. I want to go ahead and I want to use the Profiler agent. And so I can switch over to the Copilot chat. I can be either in agent or ask mode. Once you start talking to the Profiler agent, it'll automatically switch you over to agent mode. And then I can use any of the models that are available. So if I like Claude Sonnet, I can go ahead and use that. If I enjoy GPT-5, I can do that. Personally, I found that I have a lot of success with the GPT-4.1 model. It's super fast. I'm the performance guy. I really like fast software, so that's one of the biggest selling points for me. I also find that when I give it directions on tasks that I want it to do, it really focuses in on that and doesn't focus too much on coming up with its own plan. It kind of listens to what I say. So I want to use that, and I want to see if I can go ahead and I can create the benchmark and then use that to optimize performance. And so I can talk to the profiler agent by using the @profiler. When you put in the chat, it allows you to talk to a specific agent. So you could talk to the @profiler, you could talk to the @modernization agent, whatever it is that you want to talk to. In this case, we want to improve performance. So I'm saying @profiler, create a benchmark for the colored console target. And so you can see here, I then put a hash, and then I started to type out additional context that I want to give to the model. And so in this case, I have the colored console target. I could talk with the, I could specify either the specific class, I could specify a specific function in there. In this case, it's picking up the constructor, or I could specify the file. In this case, I want to do the class. And so I do that, and I get the slug in there. And so I'm saying create a benchmark for that colored console target for the class. We'll see what the profiler agent comes up with. And you can see, again, one of the reasons why I like the 4.1 model is it's so nice and quick. It gives me the plan of what it's going to do. So it's going to begin by creating a benchmark. It's going to validate the benchmark for build errors, and then it's going to run the benchmark to establish a baseline. And so you can see it's already gone. It's created that benchmark. It has a setup method. It has a log messages. It created the benchmark, but the build failed. We can run this benchmark and see. I'm going to go ahead and I'm going to keep the changes that it's created because these look good. I can look at why the build failed. I think this is related to the trimming project in this solution. So I'm going to go ahead and I'm going to build just the benchmarks, and those pass. So I'm just going to go forward with this. And so I have the benchmark now. It helped me create this. And let's say I want to edit this a little bit. So this looks good, but one of the things is we're just asking for a logger, which means it's going to give us the console logger, and it's going to write everything out to the console. @profiler, can you redirect the console output to a string builder so it doesn't affect the benchmark? And so I can rely on Copilot here to do the work, and I can give it the information that I have and the actions I want it to take. And so you can see here, I've gone ahead, I've asked it to do additional work for me. It's created a string writer with a new string builder. It's gone and forwarded that output, and then it adds a global cleanup. I'm going to go ahead and I'm going to keep that. And this looks good. I want to make one small little change, and I'm going to go ahead and do that, which is I'm going to use my own string builder. And the reason why I want to do this is I can then clear the string builder in between each iteration. And so I'm very close to having this set up the way I want. And so the reason why I made that change is as BenchmarkDotNet runs the benchmark over and over and over and tries to get statistically significant results, we're going to be appending to that same string builder over and over and growing the underlying buffer. What I want to do here is I want to clear that out each iteration. So I'm not measuring the cost of allocating new buffers in a string builder. I'm really just looking at analyzing the performance of the method I'm interested in. Another handy thing that the Copilot profiler agent added for me is in the benchmark, it logged it 1,000 times. And so I want to try and do some memory allocations on this code. And one of the nice things about doing an operation a set number of times is when I look in the allocation trace, I can look and see how many allocations occurred. And if I see an allocation that's some sort of iteration or some sort of increment of 1,000, I know that it was happening in this logger.info, and it makes those sorts of allocations jump out versus other allocations that are maybe happening with just initialization of the code. And those sorts of allocations I'm not as interested in fixing because those are just one-time costs, whereas the allocations in this logging are going to be much more important to try and reduce because you're consistently paying for that with each message that you're logging in your application. And so at this point, I think we're about ready to go ahead and start. And so we have our benchmark, and now I want to fall into that optimization loop. So I can say at profiler, run the log info messages benchmark and optimize the memory of the code that it calls. And once again, we can see the profiler agent is going to give us a plan. It's going to run the benchmark, focusing on memory usage. It's going to analyze the results to identify memory bottlenecks. It's going to propose optimizations, and then it's going to rerun. So again, it's doing that measure twice, optimize once. And so step one, run the benchmark. It's asking me, can I install these packages? And the specific package that it's looking to install is the Visual Studio BenchmarkDotNet Diagnosers. This package lets the Visual Studio profiler hook into BenchmarkDotNet and pull a performance trace. And so I want to go ahead and I want to say, yes, you can install that into my project. It's going to go ahead and build it. And as you can see, it's beginning to run my benchmarks. Now, normally, if you ran benchmark.net just as like a control F5, you would see a console application pop up and start listing off the actual benchmark as it runs. The agent is going to go ahead and do that in the background here. And so we can see some of the progress. It's starting to run the actual workload sections. It has gone and it's captured that trace. It's now saving the resulting diag session as a directory, and then it's going to go ahead and it's going to open it up in Visual Studio. And as you can see, the trace pops up, and immediately I have a top insight. And so what's actually kind of funny here is you can see Boolean boxing exceeded allocation threshold of 500. We actually added this top insight as a result of profiling the NLog library and finding this specific fix. The agent found the fix for us. We thought it was a really good thing to add. And so we added this as one of our top insight rules that automatically gets flagged. And so now the agent's finding this and it's just going ahead and it's applying the fix right away. I can click the investigate button, and then I can see exactly what's where those boxings are happening. And so you can see we have a system Boolean. We know a Boolean is a value type, not a reference type. And so when that gets allocated, what's happening is it's getting allocated and pushed onto the heap so that it can fulfill some sort of API contract. And you can see we allocated 180,000 Booleans, which amounted to about 4.3 megabytes worth of kind of garbage allocations. And if we look into where that's occurring, we can see that it's happening in these anonymous Lambda functions. I could go and I could dig into the backtrace and I could do the fix, but the profiler agent has already gone ahead and done that for me. And so you can see it noticed that it saw the 4.3 megabytes worth of allocations, and it says, I'm going to optimize the code in colored console system printer to reduce the unnecessary boxing of Booleans. I can go ahead and I can see how it's chosen to try and address this. And you can see it has this colored console highlighting rule. It seems to be evaluating some sort of condition. And sure enough, it's doing a comparison. And before it was returning the result of the comparison. But now what it's doing is it's saying boolean.true or boolean.false string. And so if we look at where this is being used, we can see the actual method was looking for a condition, and it's asking for a function that returns an object. And the fact that it was returning an object means that if it needs to fulfill that contract, it needs to return a reference type, not a value type. And so the Boolean had to get boxed and put out onto the heap to fit into that contract. And the interesting thing about a Boolean is there's only two values for it. The value can either be true or the value can be false. And so for boxing, what we can do is we can just statically allocate a Boolean true and a Boolean false, and then we can drop it out onto the heap. And in this case, if I navigate to the definition, you can see in this case, it's returning a true as a string or a false. This is probably not the ideal fix for this. I believe the first time I ran this, it gave me a better fix. And actually, let's see if we can get Copilot to fix this. And so on the other side, it's expecting a true or false value, not a string. So you returned a string, but we need to return a boxed Boolean. Can you update the code to return a cached boxed Boolean? So you can see sometimes it makes mistakes. And in this case, we have condition expression boxed true. And now if we look at this, here is where it's returning the cached versions. So you can see it has an internal static read-only object that is a boxed true. So it's taken that true value, it's put it out on the heap, and then we can just reference that. And it's done the same with the boxed false. And because it's read-only, it won't be able to be changed at runtime. And now that we got the correct fix, let's go ahead and let's keep that. And we can ask the profiler now, rerun the benchmarks and validate the memory performance. And so again, one more time, it's going to go ahead, it's running that exact same benchmark, and it's helping us validate that the change that we're making here with the boxing is what we expect. And again, it opens up the trace so that it can validate. We no longer see that same top insight that was firing. And if we go to allocations, we actually don't even see Boolean being allocated on the heap anymore. And Copilot has gone ahead and shown that as well. There's no excessive Boolean boxing present. The mean execution time is stable. And the nice part is we've allocated less junk for the GC to take care of. And so ideally, the GC is going to have less impact on our process. And so with this fix, we went ahead and we added this, this exact change found with the agent to the NLog repository. We worked back and forth with the maintainer a little bit to get the format in the way that he wanted. And then we've gone ahead and we've successfully merged it in. And so what's really cool here is that the profiler agent was able to have a successful impact on this code and help me contribute to this repository in a meaningful way when I don't really know anything about this repository. And so with that, I just want to leave you with a couple of takeaways. The first is build in the right automation. Unit tests and benchmarks really make optimization easy. As you saw with this NLog repository, it already had the unit tests, so it was easy for me to just kind of build on top of that. The Copilot profiler agent really helped with that. I could ask it to create me a benchmark, and it went ahead and it did that. I really want you to treat performance as a feature. Your customers will thank you for it. It might seem like, hey, you know, it's a couple megabytes worth of Booleans in here. That really adds up. And those small little paper cuts really start to hurt the end user experience. And the more you really treat performance as a feature and integrate it into your workflow, the better and better performance you're going to get, and your customers are really going to thank you for it. And then lastly, you really want to remember to measure, optimize, measure. It's measure twice, optimize once. If you're not measuring, you're not really optimizing. You're just refactoring code. You need to know and you need to understand where time is being spent, and you need to have a measure of the actual impact of the changes that you're making to go and validate that you are having success with that. And so with that, I want to say thank you. I hope you have a great .NET Conf. And we'd love to hear your feedback. Feel free to tag us on Twitter or developer community. Thank you.